Good morning, children. In continuation with chapter 2, electrostatic potential and capacitance, today we are going to start with capacitor and its capacitance.
Capacitor. It is a device that consists of two conductors isolated from each other so that they can be given equal but opposite charges. Because of the charges minus Q and plus Q, the electric potential of the positive conductor exceeds that of the negative conductor by an amount V. The magnitude Q of the charge on each conductor is proportional to the potential difference V between them. Q is directly proportional to V, or Q is equal to CV. The proportionality constant C is called the capacitance of the capacitor. C is equal to Q by V.
Now, capacitor is a device consists of two conducting isolated from each other so that they can give equal and opposite charges. These are the two conductors which are separating by a distance of d, and they have a charge plus Q and the minus Q. Now, according to the definition, the Q is directly proportional to the V. After removing the proportionality sign, C will come, where C is called the capacitance of this capacitor, where C is equal to Q upon V.
Capacitance. It is defined as the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between them. The SI unit of capacitance is coulomb per volt, called farad.
Now, capacitance is defined as the ratio of the magnitude of the charge to the magnitude of the potential difference between them. The SI unit of capacitance is coulomb per volt or farad.
Capacitance of a spherical conductor. Let us consider a conductor in spherical shape of radius r. If this conductor is given a charge Q, the potential at its surface is given by V is equal to 1 upon 4 pi epsilon not multiplied by Q upon R. It can be written as Q is equal to product of 4 pi epsilon not R and V. We know that Q is equal to CV. On comparing above equations, the capacitance of the spherical conductor is given by C is equal to 4 pi epsilon not R. This relation shows that the capacitance of spherical conductor is directly proportional to its radius.
Now, let us consider a spherical shape conductor having a radius r. As we know that the charge is always at the surface of the conductor. So, according to the formula, that is V is equal to 1 by 4 epsilon naught. Q is the charge upon R the radius. So, Q is equal to, just cross multiply it, you will get this value, and we already know that Q is equal to CV. Now, comparing these two equations, you will get C is equal to 4 pi epsilon naught into R, which means that the capacitance of this spherical conductor is directly dependent on the radius of the conductor. As the radius increases, the size of the conductor increases, radius increases, its capacitance is also increases.
Larger is the radius, larger will be its capacitance. This expression is true for the conductor placed in air or vacuum. If the conductor is placed in an insulating medium with dielectric constant K, then the potential at its surface is given by V is equal to 1 upon 4 pi epsilon not K multiplied by Q upon R. it can also be written as Q is equal to product of 4 pi epsilon naught K, R and V. Thus, C is equal to 4 pi epsilon naught Kr. Hence, the capacitance of the conductor in the dielectric medium is K times its capacitance in air or vacuum.
So you have to remember this formula also. C is equal to capacitance is equal to if the conductor is placed in a insulating medium where K is a dielectric constant K. Then the relation is C is equal to 4 pi epsilon naught K into R.
The parallel plate capacitor. A parallel plate capacitor consists of two parallel conducting plates separated by a distance that is small compared with the linear dimensions of the plates. Let the plates are in vacuum. If sigma is the magnitude of surface charge density on either plate, the electric field magnitude between the closely spaced parallel plates is equal to sigma upon epsilon naught, but sigma is equal to Q by A. Put the value of sigma in the above equation. We get E is equal to Q divided by epsilon naught A. Here, A is the area of each plate. The electric field between the plates is uniform and the potential difference between the plates is given by ED, which is equal to QD upon epsilon.
Now next topic is parallel plate capacitor. If sigma is the surface charge density and these capacitor, positive and the negative one, they are separated by a distance of D. So electric field is equal to sigma upon epsilon naught, that we already have done it. Replacing the sigma, that is surface charge density is equal to charge upon the area. Replace the sigma here. The electric field between the plates is uniform and the potential difference between the plate is given by EdB होता है. So replacing the value of E in this equation, you will get this equation.
Epsilon naught A. Here, D is the distance of separation of plates. The capacitance of a parallel plate capacitor is equal to Q upon V, which is equal to epsilon naught A upon D. Thus, we conclude that the capacitance of a parallel plate capacitor in vacuum is directly proportional to the area of one of the plates, inversely proportional to the separation of the plates, and independent of the charge on the capacitor.
So remember this formula. Capacitance is directly proportional to the area and inversely proportional to the separation between the two plates and independent of the charge of the capacitor. Now it's time for assessment.
Assessment. Before proceeding further, let us know how much you have learned. Drag and drop the correct option.
The capacitance of parallel plate capacitor is independent of the charge on it. The capacitance of spherical conductor is dash proportional to its radius, that is directly, and dash material are composed of the molecule that have a permanent electric dipole moment, that is polar dielectric. Let's see the answers, whether they are correct or not. Submit.
Good job.
So today's topic is over. We have done the capacitance and capacitor. Tomorrow we'll start with the new topic. These are the notes. Please copy it down in your fair notebook And further extra notes are available ERP on your school ERP. You can copy it from there, or you can also take the printout directly from there, as well as the assignment.